Welcome. Today's video will be covering a few absolute basics of environmental chemistry. First, we have to talk about matter. What makes up matter? Matter is anything that occupies space and has mass. Matter is made up of elements, a substance that cannot be broken down to other substances by ordinary chemical means. Few elements in nature exist alone. Most occur in compounds with other elements. The properties of compounds may be different than the sum of their elemental components and can change with the addition of just a single element. Elemental sodium is a water-reactive explosive metal. Elemental chlorine is a toxic corrosive gas. However, when you combine sodium with chlorine, you get sodium chloride, aka table salt. If you add oxygen to the mix, you get sodium hypochlorite, aka bleach. The next thing we need to talk about are atoms. Atoms are made up of subatomic particles. The protons, which carry a positive charge, are found in the nucleus of the atom. The electrons, which carry a negative charge, orbit the nucleus of the atom. And the neutrons, which are not charged, are located in the nucleus of the atom. All atoms of an element have the same number of protons. This equals the atomic number. The mass number equals the number of protons and neutrons in the atom's nucleus. Some atoms of an element may differ in their mass number from their atomic number because they have a different number of neutrons. These are called isotopes, and they may be radioactive or stable. We use isotopes in research to trace the movement of elements in biomes and environmental systems. This allows scientists to track and model certain types of pollution. We have to talk about chemical bonds as well. Electrons move around the atom at certain energy levels called electron shells. Each shell contains orbitals, each of which can hold a fixed number of electrons. The number of electrons in the outer shell, or valence shell, determine the chemical properties of an atom and whether or not it is reactive and will bond with other atoms. Atoms don't like having partially empty valence shells, so they fill them by bonding with other atoms. There are three types of bonds: covalent, ionic, and hydrogen. Covalent bonds happen when atoms share electrons. If atoms exert equal pull, you have a nonpolar covalent bond. If atoms exert unequal pull, you have a polar covalent bond, where one side of the compound will have a slight positive charge and the other side will have a slight negative. Ionic bonds happen when one atom donates an electron to another, making one atom electrochemically positive and the other electrochemically negative. Ions are atoms or molecules with a charge because they have lost or gained an electron. When bound to atoms of other elements, hydrogen usually ends up with a slight positive charge. Why do you think this happens? And what are the consequences of this? The consequences is that you can get hydrogen bonds forming. This is especially important in water. So what is a chemical reaction? A chemical reaction makes or breaks bonds between atoms. Reactions contain reactants and products. You always begin and end with the same number of atoms, just rearranged or separated. Matter is always conserved. As you can see in this diagram, we start out with our reactants, which are sodium hypochlorite, which is sodium, oxygen, and chlorine, and water, which is H2O. When we react these together, we get hypochlorous acid, which is HOCl, and sodium hydroxide, which is NaOH. All of the atoms are still there. We still have two hydrogens, two oxygens, a chlorine, and a sodium, but they have been rearranged and separated. Water is a very important substance in the environment and for life. It covers 70% of the Earth's surface. It is a polar molecule. While the molecule itself is covalently bonded, it can form hydrogen bonds with other molecules. This gives water some very unique properties. It has a high specific heat capacity and requires a relatively large energy input to increase the temperature of water, which breaks the hydrogen bonds. It has cohesive properties. The molecules stick together. It is also adhesive. It sticks to other surfaces. has a high surface tension that is relatively hard to break. Hydrogen bonds also give water a unique density behavior. When it freezes, is it more or less dense? If you answered less dense, you are correct. Ice floats because the hydrogen bonds firm up, spacing the atoms out further, and making the frozen water less dense than the liquid water. Water is also an excellent solvent, i.e. things or solutes can be dissolved in it. The water cycle is the movement of water from surface water to the atmosphere, back through the biotic and abiotic components of the terrestrial biome, and back into surface and groundwater. Carbon occurs in all organic compounds and some non-organic compounds as well, such as CO2. Carbon can form up to 4 covalent bonds. It provides a backbone or skeleton for most biological models. Carbon also cycles through water, soil, atmosphere, and the biotic and abiotic components of the environment. Nitrogen forms about 78% of the Earth's atmosphere. It functions as an important nutrient for plants, and many industrial compounds contain nitrogen. As with carbon and water, it has a cycle that takes it through soil, water, air, and back into the living environment. Phosphorus is an essential nutrient for living processes. It does not exist as elemental phosphorus in nature due to its high reactivity, and it is often a limiting nutrient in aquatic ecosystems. As with the other elements, it too cycles. Sulfur is essential for life as it forms the basis for some amino acids and vitamins. Sulfur exists in the atmosphere as sulfur dioxide and can form a weak acid in the presence of water. We know this as acid rain. That's the absolute basics of environmental chemistry. Thank you for watching.